Welcome. In this episode, we're going to discuss about the Unified Modeling Language. The Unified Modeling Language enables the software developer to model the software before constructed. In this model, we will discuss three things. One, we'll define what model is. We will discuss views of model, and also we have to discuss the building blocks of UML. Don't forget that to subscribe, share, like, and put your comment if you need more about the software engineering concepts. So let's define a model. Model is abstract representations of a system before constructed. So modeling simply is the representations of the system before constructed abstractly. So we'll have two types of models. The first one is the static model. This model describes what types of objects and are important for modeling system and how they are rated each other. So the the static model represents the structural aspects of the system, or it represents the snapshots or the system at rest. Every static aspects of the system represented by the static model. The other model is also called the dynamic behavior of the model will be represented by the dynamic model. So the model will represent the dynamic behaviors of the system, or this describe the lives of this object or the collaborations of the function to deliver the required functionality. The system has behavior. This behavior will represented by the dynamic behavior of or the dynamic model. The other thing, we will have the functionality of the system. So this also represented by another function, that is the functionality model. So in short, model is a representation of the system abstractly before constructed. So let's talk about overview of UML. UML is a language that is used to the system developers to model the system. So UML modeling language or unified modeling language is a language for visualizing, specifying, constructing, and documenting a software. So when we develop a model, we have to identify or specifying different kinds of requirements. We'll visualize those requirements, how it's likely its functionality, and we'll construct or develop. Finally, we will produce a document. So totally, the email enables us to accomplish such things. So in email, we are going to design or model three fundamental models. System development in email process on email focuses on three different models. So the system will have these three models, i.e. the system has a function. So the function is represented by the functional model. The system has a structure. The structure is represented by the object model. The system has various behaviors. The behavior is represented by the dynamic model. So the functional model will represented by the use case or the use case model. Functional model also called use case modeling. The other thing, the object model, also known as the structural modeling, or it describes the structures of the system. In structural modeling, the structure of the systems are will be designed. Totally, the structures are parts of the system, or this is a class, it is an object. The structure represents in terms of objects, attributes, association, and operations. So, for example, let's take this system. This system will have various structures. So these are the parts. Later on, shape will be one of the part. Polygon is another part. SCP line is another part, ellipse is another part. So in object modeling, the structures of the object represented in such way. There is a relationship. For example, polygon is a kind of shape or is types of shape, but it has its own property or its own identity. So these are, for example, polygon related with shape, SCP line related with shape, ellipse related with shape. So these are the structures or the components of the system to be constructed. The other model that we have done in UML is already the dynamic model. The dynamic model will represent the the behavioral aspects of the system. The system will have various behaviors. Yeah, the system will have various behaviors. This behavior can be represented by the dynamic model. Yeah, maybe the system will exchange different data, will exchange information from one component to the other component, or the system will interact each other, or the object in the system will interact each other. So this interaction can be depicted by the dynamic models. For example, here we have a certain system related with the ATM machine. So there are different objects. The first object or is the first is the client is an actor. There is an ATM machine is another object. So the saving account is another object. So the interaction of these three objects deposit in a such a way. So this is a dynamic or a behavioral model is. So how we are going to visualize, how we are going to view, how we are going to understand the model. So here we have five views of model. Every software developer must view these fundamental views of model, or also known as Philippe Christine 4 plus 1 model. The first is the use case view. The use case view is rated with the functionality of the system, understanding what the system is supposed to do. We have to understand what are the services to be provided by the system. What are the functions of the system? So when we do this, when we answer such kinds of questions, we are on the use case view. So this use case view is the fundamental view for the rest of views. So we can say that 4 plus 1 view use case view is the fundamental views for the rest of the view. So the logical view, the process view, the development view, and the physical view. When you design, when you develop a software, you have to understand these five views. Unless and otherwise, you will not capture the real world scenarios. Let's see each one by one. When you say the logical view, here abstractly, we are going to describe the system parts. The system will have different parts. We will have describe those parts here. Yeah, the system may have three parts, four parts, and so on. In this case, we can say or we understand what system made up of and how the system parts interact one with the other. So we have to understand what are the parts of the system, how each part is interacting each other. So we can say that this is the types of model that describes the logical uh, view of the system, the class diagram, the object diagram, the state machine diagram, the interaction diagram will be describe the logical parts of the system. The second view is the process view. In a system, there are different processes. The flow of computational steps, the flow of processes, activities. So every developer should understand or must understand what are the system's process are. So the process view will describe the process within the system, i.e. the system has different activities to be accomplished. These activities will have flows of process or sets of computational steps. So it's better to understand those computational steps in a certain system. This is can be depicted or represented by the activity diagram. The other view is already the development view. In this nature of the view, we are going to describe how the system will be developed or describe how the system parts are organized into modules and components. So later on during the code or during implementation, every part which are identified in the logical view will be modules and components. So this development view will describe how those parts and components or structures will be mapped into modules at the same time with components. So it is very useful to manage the layers within the system's architecture. So basically, this view depicted by the package and the component diagrams. The other view is already the physical view. The physical view will describe the system design. It is related with the system design. Later on, the system will be implemented in the real world machine, or the system will be installed on user's real machine. So the physical view describes about that, or is brought the system to life at the state of real-world entities. That means later on the system will deploy in a certain machine. So this view you have to understand. In this view, you have to understand how the software developer will be deployed in the real machine. What kinds of hardware it requires? What will be the architecture of the software? Yeah. What are the components to be considered during the software deployment? This is the physical view. The other thing, there's the basic thing, that is the use case view. The use case view, as we said, is that it describes the functionality of the software. So this is the fundamental view for every other four views. If we understand the functionality of the software, you can easily understand the rest of the views. You can understand the logical part of the system easily. You can understand how each part is mapped into modules and codes. And you will also understand what are the processes are in the system and so on. And finally, you also understand how each component will be deployed in a certain system. So the basic thing is you have to understand what is the functionality of the system. What are the functions? So the use case view describes such phenomena. The functionality of the system is described here, or this view typically contains the use case diagram, description, and the overview diagram. So these are the views of the model when one software developer or one software engineer will understand before modeling the software or before constructing the software. So later on, based on these views, the software will be deployed. So the other concepts that we have to discuss here today is the building blocks of UML. UML have three fundamental building blocks. So simply, in the vocabulary of UML has three kinds of building blocks. The first is things. These are the abstractions that are the first citizens of your mail model. So things will represent the real world entities such as objects, classes, associations, and so on. So the things are abstractly represent in a model. So things are the first citizen of UML. The other building blocks of UML is relationships. There is the interaction between things. There is the collaboration of between things. There is the relation between things. This relationship can be represented by a relationship or things tied together. Relationships are things tied together. For example, a student has a book, a person has a car. So a student considered as a thing, book has the book is considered as a thing. So a student has a book is indicate a kind of relationship. Person is a thing, car is a thing. So these two uh, things are relating each other. So the relationship is already it shows how things together. But these relationships are represented by a diagram. The diagram is due to depict the relationship of things in a diagram or in a pictorial representation or graphical representation. So the diagram shows how things tied together, how things relate each other. So these are the three building blocks of UML. So UML has three building blocks. In short, thank you very much.